In this video, we're going to continue with a little more work on radians and special angles. So these diagrams right here, I have just to help you as you move into thinking in radians. I wanted to look at counting, okay? So as you know, we start at the positive x-axis, and that would be 0 radians, right? And so you can see this plane on the left is divided into equal parts, and I think you can tell that each part is 45 degrees, which hopefully by now you understand as pi over 4, right? So this would be pi over 4. And I'm just going to continue counting as I go counterclockwise. And so this next one would be 2 pi over 4, which of course reduces to pi over 2. The next one over here would be 3 pi over 4, doesn't reduce. Okay, the next one would be 4 pi over 4, which of course reduces to pi. And as I continue counting, and I'm in quadrant 3 now, this would be 5 pi over 4, doesn't reduce. Next one would be 6 pi over 4, reduces to 3 pi over 2. And the next one would be 7 pi over 4. And this last one here, as I get back, would be 8 pi over 4, which simplifies to 2 pi. Okay, so that's how I remember which ones are in which quadrants. You can simply count. In this next diagram on the right, okay, you can see the plane is divided so that each angle here is 30 degrees. And again, hopefully by now you know and you have some idea that 30 degrees is pi over 6, okay? Nothing I can do to that, doesn't reduce at all. So same idea as before, I'm going to continue counting. So the next one would be 2 pi over 6, which reduces to pi over 3, that's our 60 degrees, right? The next one would be 3 pi over 6, which reduces to pi over 2, as you know. Okay, the next one would be 4 pi over 6, which reduces to 2 pi over 3. Okay, so note that was 1 pi over 3. This is 2 pi over 3. And I think from now here, you probably get the idea. This one's 5 pi over 6, doesn't reduce at all. The next one is 6 pi over 6, which reduces to pi. The next one is 7 pi over 6, doesn't reduce. The next one is 8 pi over 6, which reduces to 4 pi over 3. The next one is 9 pi over 6, which reduces to 3 pi over 2. The next one is 10 pi over 6, which reduces to 5 pi over 3. And this last one here, sorry, not the last one, is 11 pi over 6, doesn't reduce. And this one, of course, is our 12 pi over 6, which reduces to 2 pi. Okay, so that's how I think and count in radians. So the last tool that I want to remind you about when we're evaluating exact values of special angles is hopefully you recall learning about this thing called the cast rule, okay? And here we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And hopefully you remember what this means, right? This means that all are positive in quadrant 1. In quadrant 2, this means that sine is positive, so that would mean that cosine and tangent are negative. In quadrant 3, tan is positive, so the others, sine and cos, would be negative. And in the last one, cosine is positive. Okay, so we're going to use that to determine exact values with angles that are beyond the first quadrant, okay? So all of these 3 questions here in this example, they are literally just going to equal a number, okay? But there's sort of a lot of a thought process that goes on behind the scenes to come out with that number, okay? So I just want to illustrate the thought process a couple of times, and then you're going to practice with a whole bunch of these, okay? Okay, so for this first question, we're trying to determine the exact value of cos of 5 pi over 3. First thinking for me is 5 pi over 3. Where is that? Okay, that's an angle in quadrant 4. So this is sort of my thinking here. So that tells me we're doing cosine of an angle in quadrant 4. So the answer is going to be positive, right? That means our answer is positive. So now we find the related acute angle. The related acute angle is pi over 3. That's the angle in quadrant 1. So I need to find the cos of pi over 3. So I'm using my special triangle to figure that out from last day. And I know that that is a half. Okay, so cos of 5 pi over 3 is exactly the same value and with a positive sign as we figured out. Okay, so I'm using this information to come up with the answer. Okay, let's try another one. Try and do as much of the thinking and figuring out as your own, and pause the video if you can. Okay, so sine of 11 pi over 6. Again, I'm thinking the angle 11 pi over 6. What quadrant is that in? That's 1 less than 12 pi over 6. So again, that is quadrant 4. Now, right away, the sign of something in quadrant 4 is negative. Okay, so right away I know that my answer is going to be negative here because I'm in quadrant 4. Then I'm going to look for my related acute angle, which is pi over 6. So I want from my special triangles the sine of pi over 6, which is a half. And so the answer to our question is the same value, the same half, but it's negative because we're in quadrant 4. Okay, so that's the final answer right there. That's what you would be needing to write. All of the red is just my thinking. Okay. Okay, and this last one is we want the cotangent of 3 pi over 4. Okay, similar thoughts. 3 pi over 4, what quadrant are we in? We're in quadrant 2. Okay, in quadrant 2, tan is negative, so is cotangent, so is the reciprocal, so our answer is going to be negative. Okay, and now I'm looking for the related acute angle, so pi over 4. For me, I just go with all of the basics, so I think of tan of pi over 4, and I know that that's 1, or if you like, 1 over 1. And so it's the reciprocal of that, which is, of course, still 1 in this case. So using all that information together, I know that the answer is negative, and it's the reciprocal of tan of pi over 4, which is still 1. Okay, so in your practice today, you're going to practice a whole bunch of those. Now, the next thing I want to teach you about is how to deal with these special angles. So the one on the axis arms, the ones not in a quadrant. So that's our 0, our pi, our 2 pi, our pi over 2, and our 3 pi over 2. So to do this, we are going to consider the unit circle, okay? And you might be asking, what is a unit circle? Or maybe you remember hearing about this before. And that is a circle where the radius equals 1. Okay, so if I have this picture down here and I have this arm right here, I know that the radius is 1. And if I drop that down just to get my points, I know that this length right here is x, and this length right here is y, and they have created a right angle triangle. And this angle right here is my angle theta. Now, from this picture, you can see that sine theta would equal y over r. And if the radius is 1, then that means that sine theta equals y, right? And similarly, cos of theta would equal x over r. And again, same idea. If r is 1, then I'm simply left with cos theta equals x. Okay, and this is then therefore what tells us that when I have a point x comma y on a unit circle, the coordinates x, y represent cos of the angle theta and sine theta. How do I remember that? X comes before y in the alphabet, and so does C come before S. Okay, so alphabetical order. Now from this picture, we also know that tan theta would equal y over x. So that's a reminder that tan theta equals sine theta over cos theta. And you should have learned that before. That comes from your grade 11 understanding. So now I'd like you to imagine this unit circle, okay? And again, it's a unit circle, so the radius is 1. And I'm just going to put in some points. That means that this point right here is 1, 0. That means this point right here is 0, 1. That means this point is negative 1, 0. And that means this point right here is 0, negative 1. And I will just remind you as well about our angles from all of our counting. This would be 0 radians. This would be pi over 2. This is pi. this is 3 pi over 2, and then all the way back, this is also 2 pi. Okay, so we can use this idea to figure out, let's say, the sine of pi over 2. Okay, I'm going to set up a little table. You're going to need to pause the video and set up the same table. Okay, and we're going to use this idea to fill in the table. Okay, so the first one that I'm going to look for here is the sine of pi over 2. Okay, so I'm going to go to pi over 2, and I know that sine is the y value, so the sine of pi over 2 is 1. I know that the cosine of pi over 2 is the x value, so the cosine of pi over 2 is 0. And then the tan of theta is sine over cos, sine theta over cos theta, so it's 1 over 0 here, which means that here we write does not exist. It's undefined, if you like, or does not exist. Okay, similarly, I'm now going to move to pi. Okay, so pi is over here. So we know the sine of pi is the y value, so the sine of pi is 0. We know that the cosine of pi is the x value, -1. We know that tan theta is going to be sine theta over cos theta, so 0 divided by -1 is 0. Okay, you pause the video and see if you can fill in the rest of the table. Okay, so important to understand that all of these values, you can get some of them and verify it from your calculator, but if you use this special tool, it's very easy to justify each one and to not get confused when we're trying to find reciprocals or any of those. Okay, so now I'm going to show you quickly how we put all of this exact value sort of radian knowledge together into a question. Okay, so you will see questions that look like this. Determine the exact value of this expression, okay? And I need all exact values. Really, I should not be touching my calculator at all when I try to do a question like this. Now, hopefully you can see that I need 4 exact values. I need the sine of pi over 4. I need the cos of pi. I need the sine of 2 pi over 3. And the tan of 7 pi over 6. So you're going to use all of your tools from the past couple days to get 4 exact values. Okay, so what I like to do is just set it up. I need 4 exact values, and I'm going to slot them in to the brackets. So using my tools at the left here, my special triangles, or my axes on from above, I know that sine of pi over 4 is 1 over root 2. Okay, you can rationalize that right from the beginning, or you can rationalize it at the end. I'm going to do it at the end to show you, but if you did it at the beginning, things would work out really nicely as well. Okay, cos of pi from above, I'm going to go to pi on my diagram, and I know it's the x value right here. So I don't memorize any of these. I draw this picture to help me out. So I know that that is -1. Sine of 2 pi over 3, I know that that is in quadrant 2. And it's sine, so it's positive, so I just need the sine of pi over 3. So I use my special triangle to figure out that that's root 3 over 2. And the last one, tan of 7 pi over 6, I know that's in quadrant 3, 7 pi over 6, and that's tan, so that's also positive. So then I can just think about what is the tan of pi over 6, again for my special triangle, and that's 1 over root 3. Okay, so hopefully you practice getting all those values. This is how we put them together, and now I'm going to just quickly show you how to simplify it. Okay, first thing I'm going to do is, of course, simplify these fractions and multiply them. So this first pair, I get -1 over root 2, and then I'm going to subtract. In this second one, the root 3's obviously cancel, and so I'm actually just subtracting a half. Okay, so I'm subtracting 2 fractions here. So the first thing I need to do is make a common denominator. So the common denominator is 2 root 2. The numerator on the top left becomes a -2. And the numerator on the top right becomes a minus root 2. Okay, and then I have my radical in my denominator, so I must rationalize. And so to rationalize, I'm going to multiply by root 2 over root 2. Okay, root 2 because that's what I have in the denominator that I want to get rid of. Just don't forget that this root 2 here on the top has to get distributed and multiplied by both pieces in the numerator. And so in the numerator, I end up with -2 root 2. Subtract, I'm going to multiply root 2 by root 2, and I just have a 2 there. And then on the bottom, I have 2 times root 2 times root 2. So that ends up being 2 times 2, which is 4. Okay, and again, now you can see that all of these three pieces, this, and this, are all divisible by 2, so things simplify just a little bit, and we end up with negative root 2 minus 1 over 2. Okay, so we're going to need to practice that simplifying just a little bit. And I have one more type of question that you will see. So this example says theta is a second quadrant angle and cos theta equals negative 4 over 5. And we are going to state the coordinates of a point on the terminal arm and find the other 5 associated trig ratios. So we have cos, we need to find sine, tan, and all of the reciprocals. So the first thing I tell people when you see a question like this is you need to draw a picture. Okay, as soon as you see something like that, you need to draw this triangle and this angle. Okay, so theta is a second quadrant angle, so your terminal arm is in quadrant 2. It doesn't matter where you draw it in quadrant 2, but your terminal arm is in quadrant 2. And this is actually the angle that we're talking about, but we actually use the related acute angle beta here to help us figure this out. Okay, so here's my triangle, and if cos theta, but we're using cos beta, it's in quadrant 2. So this is our angle right here that I'm referring to. If cos theta equals negative 4 over 5, that means that I have a negative 4 here. Hypotenuse of my triangle is 5. And I would be looking to find this y value right over there. Okay, and of course this is a right angle triangle, so you can go ahead and use Pythagorean theorem to find out what y is, to then be able to figure out what is this point, let's call it P, on the terminal arm. So just using Pythagorean theorem right here, I can set that up. I know that y squared is going to equal 25 minus 16. Y squared is going to equal 9, and therefore y is 3. Now, y, of course, could be a positive or negative 3, but based on your picture of being in quadrant 2, you know that this is positive 3 right there, right? That only makes sense in this scenario. So you use whichever one makes sense, and that means our point here is negative 4 for the x value and 3 for the y value. So once you've drawn this picture and used Pythagorean theorem to solve for the unknown, now I can basically ask you about any of the ratios, and you should be able to find them. Okay, so let's start with sine theta. Okay, so to find sine theta, I'm going to go to my related acute angle, and sine theta is 3 over 5. Using a similar process, I know that tan theta, again, using my related angle, tan theta is going to be 3 over negative 4. And remember, it doesn't really matter where the negative is. The negative now just means that the ratio is negative. Okay, and using all of that information, I can find the reciprocals as well. So cosecant theta would be 5 over 3. Cotangent theta would be negative 4 over 3. And from above here, secant theta would be 5 over negative 4. Okay, those are the other 5 associated trig ratios. So you are going to practice some of these ideas.